Alright, so now let's put everything together from start to finish to be able to use the normal distribution to approximate binomial probabilities. So the first thing we want to do is just make sure that we can use the binomial distribution first off. So make sure you have a binomial probability in the first place. So make sure that you know what your N, P, and Q are. The second step is you want to make sure that you can use the normal distribution to actually approximate the binomial variable R. So remember, to do this, you need to ask yourself the two questions. Is NP greater than or equal to
10,
and is NQ greater than or equal to
10,
Remember, if either one of those questions you answer no to it, then you cannot use the normal approximation. The third step, so once you know you can do this, find the mean and standard deviation for the normal distribution, which is going to be the same as your mean and standard deviation of your binomial distribution. So mu is going to equal to n times p, and sigma is going to equal to the square root of n times p times q. Next, you want to get equality and then apply continuity correction. And then get from there. So to do that, you want to add or subtract 0.5 depending on if you have left hand, right hand, or both endpoints. And from here, shade your normal area. And then from there, it's the exact same stuff we did back in sections 6.2 and 6.3. So from there, you find your z-score, find the probability using your z-score table. And that's it. So let's look at one of these all the way through. So 62% of adults in the U.S. have an HDTV in their home. You randomly select 45 adults in the U.S., ask them if they have an HDTV in their home. What's the probability that fewer than 20 of them respond yes? So this is the one we already looked at earlier. And so remember, we found out that yes, you can use the normal approximation in this case. So we had specified N was 45, P was 0.62, or sorry, 0.45, no, 0.62. So P is 0.62, and Q is 0.38. And so we had already found, remember, NP and NQ. We had already found these. We found NP was 27.9, NQ was 17.1. Both were larger than or equal to
10.
And so that told us we could do it. So then we know mean, in this case, mu is our N times P, which was 27.9. We've already calculated that. And standard deviation sigma is going to be about 3.26. So we already calculated that earlier. Alright, so we know that we're trying to find the probability that fewer than 20 of them respond. So this is R is less than 20. So this is the probability R is less than 20. So the first thing we need to do is get our equality. So this is going to be, remember, since it's less than, we're going down. So this is going to be R less than or equal to 19. And now let's figure out, okay, left hand or right hand. So sketch out a number line. There's 19. And it's less than or equal to that. So this is our right hand endpoint. So we have to add 0.5 to convert to x. So this is the probability that x now is less than or equal to 19.5. And it's perfectly okay if after you convert to x, if you omit the equality. So you might see it written as just x is less than 19.5. That's okay. Because remember, once you've converted to a continuous random variable, the equality itself has no meaning because we know the probability that it's equal to some value is just equal to 0 at that point. So we can omit the equality without changing anything at that point. I'm typically going to write it with the equality just so that we remember the original probability was with equality since it was binomial. Alright, so we've got probability x is less than or equal to 19.5. So now let's go ahead and convert to z. So we're doing another calculation. So z now less than or equal to, so our z-score formula, 19.5, our data value, minus our mean of 27.9, divided by our standard deviation of 3.26. So this becomes probability that z is less than or equal to negative 2.58. So now let's sketch our normal distribution, see what we're looking at. So here's our z distribution. Negative 2.58 is about here. and we want less than or equal to. So we're looking for area to the left. So we just go to our table. And on our table, we're going to look for negative 2.58. So remember, you go down to negative 2.50 here on your left-hand column, and then go to 0.08, so our hundredths digit. Find where that row and that column intersect, in this case 0.0049. And because we're looking for less than or equal to, which is what our table gives us, that is our probability. So approximately 0.0049. All right, so let's look at one more example. So a survey reports that 62% of internet users use Google Chrome as their browser. You randomly select 150 internet users and ask each whether they use Google Chrome as their browser. We want to know what is the probability that exactly 90 will say yes. So the first thing we need to do is make sure that we have a binomial probability distribution. And so we have 150 trials. We have two outcomes. We're going to assume they either use Google Chrome or they do not use Google Chrome as their browser. So here, since we're looking for the probability that they say yes, in other words, they use Google Chrome as their browser, then our probability of success, P, is going to be the probability that the individual selected uses Google Chrome, which is 0.62, which then means Q, which is 1 minus 0.62, so always 1 minus P, is going to be 0.38. And so then we need to, so we do have a binomial distribution. So now we need to make sure that the normal approximation can be used. So n times p is going to be 150 times 0.62. And that is 93, which is definitely greater than or equal to 10. So that works. N times q is going to be 150 times 0.38, which is 57, which is also greater than or equal to 10. So the normal approximation can be used here. So now we need to find our mean and our standard deviation. So mu we know is n times p, so that's 150 times 0.62, which is 93. And then our standard deviation, square root of mu times q. So here that's going to be the square root of 93 times 0.38, which is going to be 5.94. Now let's set up our probability. So we're looking for the probability exactly 96 people will say yes, that they use Google Chrome as their web browser. So we're looking for the probability, if we think of it that way, that really our binomial random variable R is between 96 and 96. So that's really the same thing as saying equals 96, right? You're in the interval between 96 and 96. But then that lets us do our continuity correction. So that's the probability that 95.5, if we subtract 0.5 to get our lower bound, is less than our normal random variable x, less than or equal to our upper bound. So we add 0.5 for that continuity correction of 96.5. Now we convert to our z. So we're back to our normal process. So 95.5 minus our mean of 93 divided by our standard deviation of 5.94. It's going to be less than or equal to z, less than or equal to 96.5 minus 93 divided by 5.94. So we're looking for the probability that our z-score is between 0.42 and 0.59. So now we would sketch that out. So draw our normal distribution. There's z, mean of 0 in the middle. And so 0.42 somewhere about here. 0.59 maybe right here. And then we're shading that region in the middle of those two. All right, so we look up our two z-scores. So we look up 0.59, our bigger z-score, and we get an area to the left of 0.7224 minus the area to the left of our smaller z-score, 0.59, which is 0.6628. And we do that subtraction to get our final probability approximation, which is 0.0596.